Okay, so in your packet from yesterday, we're going to pick up right at question number 16. And again, we're going to jump around a little bit here. So 16, you're going to need a calculator for. So it has to identify two angles, positive and negative, that are coterminal. So coterminal means I add and subtract what number? 360, exactly. Doesn't matter the order. So I'm going to take the negative 495 degrees, and I'm going to start by adding on 360. And that is not going to make this positive, so you're going to have to do it twice. All right, so negative 495 plus 2 times 360 is 225. That's it. Nice, quick, easy one. Now you learn a negative angle that is coterminal. You have many choices for this, just so you're aware. You could just do negative 495 plus 360. This would be an entirely acceptable answer. Or you could do negative 495 minus 360. Again, both full credit. So negative 495 plus 360 is negative 135. And alternatively, you could do negative 495 minus 360 is negative 855. That's 16, pretty good. Okay, I'm going to skip 17. Pass down to 21. This is the formula that we made use of, but it is not on your formula sheet. When you are given a circle and a radius, this is what we call the subtended arc length formula. S equals R theta. Anytime you see circle with your radius, the only trick to this is that theta must be in radians, and if it's not, you do a little conversion. So this is back from your first packet. You guys had this on your first quiz a couple weeks back. So we have, in this case, our radius is equal to 3.4. So you know that. And your angle is 3 radians. So actually, it does not even need a conversion. All right. So you're going to find the length of the subtended arc. Again, if you are a picture person, think of a pizza. And your subtended arc length is going to be the crust. So here is theta, here is R. So answer, you're just going to plug these in. So I have S equal to 3.4 times 3. And this comes back as 10.2. That's it. Nice basic easy formula. So one more, we haven't seen it in a while. It says a ball is rolling in a circular path that has a radius of 6. What is the distance that the ball has rolled, so around the arc, when the subtended arc is 43 degrees? You have to first take this, come off to the side and convert it. So on your formula sheet, look for degrees. You're going to multiply by pi over 180. In the calculator, I typed in 43 divided by 180, math, enter, enter, and actually I find that it doesn't reduce. That's okay. I have a radius equal to 6. And again, I am looking to use S equals R times theta. So S is equal to 6 multiplied by 43 pi over 180. And again, that just goes right in your calculator. You don't need to show any further work. So 6 times parentheses, 43 pi and over 180. Enter. I got 4.5. And then done. Okay. Are we good on 21, 22? Again, anytime you see a circle problem with subtracted arc length, that is the formula S equals R theta. Okay, so 23. In which quadrant does theta terminate? You are looking for where sine is negative, cos is positive. So I need to sketch here my diagram. It goes A, S, T, C. I am first and foremost looking for where sine is less than 0, meaning I want where sine is negative. So I'm going to do this in blue. Over here, sine is negative in quadrants 3 and 4. Now I look at cosine, I'm going to do that one in purple. So this, I'm looking for where it's positive, and I'm going to put those check marks. And which two quadrants is cosine positive? Yep, 1 and 4, awesome. So where's my overlap? Quadrant 4, that's it, that's your answer. Remember Roman numerals? There we go. You got one more of those on the back. Let's do it just for repetition. But that's it, those are pretty quick. All right, now I'm looking for my reciprocal functions. A, S, T, C. All right, cotangent. What does cotangent go with? Tan. And I'm going to put two check marks where tan is less than 0, negative. So where's tan negative? Yep, excellent, 2 and 4. I'm going to use orange now, and I'm going to do cosecant, which is associated with sine. Yep, because those signs are always, the letters are always opposite. And greater than 0 implies that this is positive. So where is sine positive? 1 and 2. So what answer is quadrant 2? Okay. Does everyone feel confident with ASTC? Perfect. 24, cross it off. 25, let's do it. We did one of these yesterday, but again, just for reinforcement. You have secant, you have cosecant. I know this seems kind of silly. Write them out. So SEC stands for secant. And this abbreviation stands for cosecant. What's the only difference between those two? So your prefix is different. So what does co stand for? 90. These are called cofunctions. But again, the only important thing for you to remember is you're going to add them equal to 90. Those are cofunctions. Ignore your equal sign. You're going to take 5 theta plus 14 equal, plus 2 theta minus 1 equals 90. All right, and then just solve. So I am left with 7 theta plus 13 equal to 90. Minus 13 minus 13. So I get 7 times theta equal to 77. And then I'm going to divide by 7, so theta is equal to 11. Squeeze that in there. I know it's kind of hard to fit. Divide by 7, divided by 7. Okay. Again, those questions are very easy as long as you remember how to set them up. Okay, so 26 is a quick trick review question. I'm actually going to rewrite this. We typically work with them like this. 4 cos x minus 2. So first tell me, what is the amplitude on this? 4. Yep, so amplitude is equal to 4. And midline is equal to -2. Yep. I want to find my minimum value here. So minimum value is going to be midline minus amplitude. So that is equal to my minimum. So I'm going to do -2 minus 4, which means my minimum occurs at -6. Okay, just like you did last week. 27. We'll do it quick. It says you have high tide in Boston with midnight. The water level at high tide was 9 feet. And at low tide, it was equal to 0.1. Assuming the next high tide is exactly 12 hours later, that is the period of your high tide, low tide. And that the height of the water is given by a sine curve. Find a formula for the water level in Boston. So we know right now that your minimum is equal to 0.1. We know your maximum is equal to 9.9. We know the period is 12 hours and then it repeats itself again. And we know we're going to make it say y equals something for sine of x. Okay. So the first value we need is, let's go and get the amplitude. So your formula for amplitude, you guys just did it and you did a great job with it. It's max minus min divided by 2. So this is equal to 9.9 minus 0.1 divided by 2. All right, so 9.8 divided by 2, which is equal to 4.9. Next value, we need to find C. And we're going to go max plus min divided by 2. And this is going to be 9.9 plus 0.1 divided by 2, which is 10 divided by 2, which is 5. We have one more to find, and that's your frequency. So lastly, you're going to use the formula. The period is equal to 2 pi divided by frequency. And again, you're going to be able to find one of those values in the context of the question. So we need a period. So 12 is equal to 2 pi times divided by b. Cross multiplying, you get 12b equal to 2 pi. And then divide by 12, divide by 12. So that reduces down to pi over 6. Okay. Lastly, I just take those 3 values and I substitute them in. So my answer is going to be y is equal to 4.9 sine of pi over 6 multiplied by t, or x. We use t because this was a real world example, and plus 5. How do we feel down to 27? Pretty good? Okay, change gears, please, and find some paper to write a couple of questions. You don't really need to worry about any of these other ones. We're going to do some exact value to start here, because again, I'm going to give you ones that I think you need the most work on. Extra examples. I'm just going to keep that short. The number 1 is exact value. Again, this is what I've noticed, a little bit more practice with. I'm going to give you cotangent 5 pi over 4. I'm going to give you 2 of these. I have a feeling for some of you, this is probably the hardest thing. Again, it's really involved. There's a lot of steps that you want to take into consideration. All right, so here's 2 of those. So what do you suppose we should do on the left-hand side with the radian measure? Convert it. Yep, you can do it 2 ways. You can cross off the pi, change it to 180. That's the shortcut. Or you can look at your formula sheet, find where it says radians, and it's going to say take what is up there and multiply it by 180 over 5. Either way. If you do it off the formula sheet, it just adds an additional step, but still not long. So I'm going to go 5 times 180 divided by 4 is 225. Okay, so this is where some of you stopped yesterday. What do I need to do with the 225? What quadrant does that exist in? Yep, perfect. So now I got to plot it. So step 2 is plot it. It's over in quadrant 3. Okay, again, you're off to a great start. You're not done. How do I get the reference angle? What's the rule? Minus 180, perfect. 225 minus 180. This should turn it into an angle that is familiar to you. 45, that is familiar. So I go ASTC. And in quadrant 3, tangent and cotangent are actually both positive. So positive cotan of 45. I'm almost done. What you need to do next is go off to the side and think about what is the tangent of 45 degrees. You can either have this memorized or you can draw your triangle. 45 degrees is an isosceles triangle in which across from both 45-degree angles, your legs measure 1 and your hypotenuse is the square root of 2. So if I do tan of 45, I do opposite over adjacent, which is 1 over 1. I take 1 over 1 and flip it, which is still just 1. And again, I'm leaving the plus sign in front just so that the more times you see it, hopefully the less you'll forget to check for ASTC. Okay, so now let's do letter B. Letter B, what can I do to turn this angle into something that's positive? Plus 360. Just to turn it positive. Yep. So negative 150 plus 360 is 210. Now I'm going to plot it. So 210 also falls into quadrant 3. I'm going to do the same rule. I'm going to do 210. Subtract the 180 degrees that makes up that straight line. And I get 30. And 30 should be familiar as well. So I'm going to quickly label on here ASTC. And the tangent is also positive. So I'm going to do positive tan of 30. And now I'm going to pull your 30, 60, 90 triangle, or if you have this memorized, you're not required to draw the triangle. So here's your 30, 60, 90. Across from the 30 is always a 1. Hypotenuse is 2, and across from 60 is the square root of 3. Therefore, the tangent of 30 is opposite over hypotenuse, which we then rationalize by multiplying top and bottom by radical 3 over radical 3. Okay, so answer is radical 3 over 3. Lots of partial credit on those because, again, there are many steps involved. How do we feel on those two? Okay, again, I'm seeing a lot of you you're starting it the correct way and you're just not taking the last 2 steps. So again, be confident, you got this. You just have to take them and plot them from after your second step. Number 2, I'm going to give you a unit circle question to have you sketch this as well. Number 2, I'm going to say as theta increases from pi to 3 pi over 2, comma, sine theta does something, and cos theta does something. And I'm looking here for, do they increase or decrease kind of thing. This would be like a multiple choice question. All right, so if you think about these conversions, what's pi equal to? Yep, 180. And what was 3 pi over 2 equal to? Unit circle, so it is 270. So you're going to sketch your unit circle and figure out what happens with sine and cosine. So unit circle is 1, 0, 0 degrees, 0, 1, 90 degrees. Over here is -1, 0, 180. And the one we are also looking for down here is 0, -1, 270. Now I'm looking to remember that on the unit circle, xy corresponds to cos and then sine. Okay, so first let's look at sine. So what is sine doing from 180 to 270? So go to 180, your sine value is 0. I'm going to say sine 180 equals 0. And then what is the sine value at 270? -1. Yep. So what's happening to our sine, increase or decrease? Went from 0 to -1. So it decreased. So we do the same thing with cosine, just look at what happens here. So I want cos of 180, cos of 270. So cos of 180 and cos of 270. All right, so over to 180, cosine is -1. Down to 270, cosine is 0. So what happens with cosine, increase or decrease? Increase, yep, they just do the opposite. So that increase. Okay. I'm going to give you just one more, I think. So lastly, I'm going to skip down to number 3, which for me, this is like number 7. Let's give you one more unit circle, one quick. I'm going to say given let's do this one. Coordinate P on the unit circle. Given coordinate P on your unit circle, which is going to be -24, 25, comma 7 over 25. And what I want you to do is find your 6 trig functions. So find sine theta, cos theta, tan theta. It'll take you longer to write the question to actually do it very quick. And then we'll find cosecant theta, secant theta, cotan theta. Just extra practice. Okay. So on the unit circle, and again, you can use this question anytime you see unit circle. So on the unit circle, I want to remember that the x value is cos and the y value is sine. Yep. So sine of theta is 7 over 25. No work you have to show. Cos is -24 over 25. And now you have to show some work. So tan is equal to sine over cos. I'm going to do that over here. So tan is equal to sine over cos. And you're going to do a quick change flip and then cancel. So I get 7 over 25 multiplied by 25 over -24. And then you're going to notice that those cancel. Right? So the answer is -7 over 24. And then last, I'm going to flip them all. So easy part. Cosecant, take it and flip it. So 25 over 7. What about secant? Negative 25 over 24. And lastly, cotan would flip to be negative 24 over 7. Is everyone feeling okay in regards to those questions? Good. Perfect. Your test is only 14. Right on your Google Doc, I did list the topics specifically that you want to make sure you study. And I kind of summarized it for you too, just because I want you to be prepared and confident. And it doesn't want to share that on me. So right on here, if you look, I listed these. So your bullet points, you want to know the 6 trig functions. We just did that. Convert from degrees to radians, radians to degrees, exact value cofunctions, ASTC, S equals R theta, and then all your features of your trig graphs. Anything you guys want to ask about? Okay, you got like 5 minutes to just get yourself situated then.